I think I need the presenter. Yeah, now I'm fine. Hello! Hello, everybody. So, we are ready. So, seems like this is going to be the last speech, and I know what you're thinking. Actually, I'm the only one preventing you to go to the after party. So, I think I will be fast. I hope so. So, today we are going to talk about the awesome architectures in Magento 2.3, and I know what you're thinking probably is, why are you going to talk about software architectures in what is supposed to be a rookie track? That's a nice question. Well, the first answer, of course, is that I will make it easy. And the second answer will be much more clear later. Before, just a brief introduction about myself, just in case you never heard about me. My name is Riccardo Tempesta, and I am CTO at MageSpeciallist. It's an Italian-based company verticalized on Magento solutions. I'm also one of the top 5 contributors of 2018, as well as a Magento community maintainer and a Magento master for 2019. And most of the people know me under a different name. That is actually the Rick, and this is my actual picture. Don't trust the people that say that I use Photoshop. They are liars. It's not true. So, disclaimer number 1 before we go. The next slides contain a personal interpretation that might differ from the official Magento architect's position. In other words, I'm not a Magento employee, so basically there will be no official roadmap here as my personal interpretation. I think it's almost the same as the Magento architects, but feel free to ask them to have some official position. Disclaimer number 2 is that my English sucks, but you don't want to try my Polish. I cannot pronounce one single word. Actually, I have problems with your name, so you can imagine how strong it can be for me to pronounce something. So, why this speech? Actually, this is a rookie track. So, why software architecture? I think that facing Magento for the first time, especially Magento 2, can be a little bit confusing, I think. It can be quite stressful and frustrating. Yeah, right? Do you think so? A little bit, yeah, just a little bit. So I want to give you something to understand exactly what are the main ideas behind Magento 2, so you can understand something more. Because I noticed this, actually it depends on your, I think, seniority, because I noticed that a lot of junior developers thinks that Magento 2 is very easy to face. For example, they have this guy in my team. His name is Mark. He's a very smart guy. He's just 23 years old. And he always says me that becoming a Magento 2 developer is not stressful at all. So absolutely. Yeah, of course, come on. It's a joke because he's not 23, he's of course 20. So it's not, of course, but where this stress comes from? Actually, I think, and I am becoming serious, and I can assure you it's quite uncommon for me. This stress comes from some confusion. And I want to approach a very philosophic level this time, so I want to explain to you what is confusion in this case. So confusion comes from the Latin word confundere, that is made by cum plus fundere or fusus, that means melted with. So melted together. So this is confusion. So basically what I want to mean is that if you're trying, oh, this is very Sheldon Cooper-like definition, yeah. When you try to approach Magento 2 using your previous knowledge, because basically you have probably some knowledge coming from, it can be Magento 1, it can be Laravel, Symfony, whatever, WordPress, so whatever you're coming from and you're facing Magento 2, basically you're using your old experience to explore this new world. So basically you're melting them together. This is confusion, actually. This is where the confusion comes from. So you cannot distinguish anymore which part belongs to what. Confusion, despite what you can think is a good state, because usually after confusion, you create something new. But of course you have to move out from confusion, otherwise it's a mess, as you can imagine. And I want to give you some tools to get out of this confusion. The first thing you have to understand is that Magento is a very complex software, of course, we all know, with an extremely complex code base. And to understand how to face this complexity, I want to open a parenthesis about the developing process. Every developing process basically starts from, impressive, a developer that is writing a code base that is compiled or interpreted or whatever in instructions that are run by a CPU. if we have a very complex software, actually this is not a problem for CPUs because at the maximum you can have, let's say, a slow software, but you can add more computational power. So at the end, it's not exactly a problem there. The real bottleneck when the software becomes complex, it's us. Because basically, when we have a very complex software, we become the real bottleneck. Because we spend most of the time reading the software. Maybe, probably it happened to you as well. So you develop something, it grows because the customer keeps asking new things. And after some months or some year, you try to add some new feature, and you have to take time to understand what you are doing, what you're trying to do. So basically, you spend the 95% of your time in trying to understand what you are trying to do with the software, and a few percentage of the time in writing new code. Of course, we have to optimize this process. How we can do that? Of course, we can add structures, raise abstraction, reduce the cognitive load, so make the software more easy to read, the code more easy to read. And what are the tools? Well, you probably know them. You can organize in methods, classes, modules, applications, and whatever. The interaction between all these parts is what is called architecture. This is why I want to show you how Magento is facing this approach. And to do that, I have to show you something about the software evolution from the 90s to nowadays. And I will do like every legit Italian should do, talking about pasta. This is not a joke, because in the 90s, we got the so-called spaghetti coding. I will explain you later why. I know it's dinner time, so every one of you is very attracted from this slide, especially me, but trust me, I'm Italian, I never joke about pasta. So in the 90s, we had the spaghetti coding, also known as copy and paste. Then, in the 2000s, we have the right pronunciation is not lasagna, it's lasagna. I told you I'm very serious about this. Lasagna coding, also known as the layer monolith. I will explain you later what it means exactly. And then, in the 2010s, we had the so-called ravioli coding, also known as microservices. Yeah, it's very fun. Do you want to take some picture? OK, that's perfect. So let's start. I promised you I will start explaining you what it means exactly. So 90s, spaghetti coding era. Why spaghetti? Because at that time, the software was something, magic. No one knew exactly how an application was working. And the all important thing was the user interface. Then the user interface was connected to a black box working somehow. But when you open the black box, you got chaos. Everything was connected with everything. So basically, the spaghetti coding is not an architecture. I mean, it's something that of course you should not be doing. Is chaos, because if you remember, probably at that time it was mostly linear programming. So the code was full of go to, go sub. If you're old like me, you probably remember. So when you try to move something or change something, you were breaking something somewhere else. So that was the main point. So basically, it was no architecture at all. Totally. So it was extremely hard to maintain. It was requiring a very high cognitive load. So to understand what the code was doing, it was very hard after some time. And it had a very bad scalability. So at the very beginning, the software was easy to develop, to start. But at a certain point, you find you reach the evolution limit of the software. So it's easier to refactor that software from the beginning than to expand that software. So this is why we come to the 2000s, and we approach the lasagna coding era, the so-called layer monolith. That is a direct consequence of the object-oriented programming, actually. Why layer monolith? Why lasagna? Lasagna, is made of slices, layers, and if you remove one layer, of course, the lasagna collapses. This is almost the same with the software. So in the layer monolith, every upper layer depends directly on the underneath layers. A simple example is a web application. In a web application, you have HTML layer, you have PHP layer, and you have database layer. Of course, you need all of them to have the web application, and you cannot think to remove one of them, otherwise everything is simply collapsing. So you cannot say, I want to remove the PHP layer. because it is not working. Or from another point of view, this is in Magento 1, you had controllers that were connected to model, that were connected to resource model, that were connected to database or whatever, and so on. And Magento 1 basically was following this model, mostly. So basically, in the layer approach, we had, this is just an example, of course, this is just to explain you. So if we had customer catalog in quote, we had to split them in layers. And every single layer was depending on the underneath layer. So basically, our software was organized horizontally. So this was a kind of horizontal model developing. It is not a problem, actually, but the problems come from this scenario, in which each part must communicate to the other. So for example, the customer functional area needs to access information from the quote. The quote must access information from the catalog, and whatever. So basically, you have each functional area interconnected to another area. So basically, this is why it's called layer monolith, because you cannot think to remove one single part, because otherwise, all the system collapse. So basically, you have modules, but you don't have modularity. That is one of the main problems. Yes, this is one of the main drawbacks, again, is that we cannot, for example, deploy one single layer. So independently, I mean, we cannot say I'm going to deploy only HTML and not PHP and database. You cannot say I can scale only the customer functional area, because if you want to scale them, you have to scale mostly all the systems. So basically, what was the scaling model of Magento 1 or any other application using this pattern that you may have used? So basically, you multiply the front, and that's it. Now we come to 2010, so nowadays, the Ravioli coding era. You know, Ravioli, they are almost independent each other. They have nice stuff inside. Here again, I'm becoming hungry, honestly. And how it's organized, it's also called microservices. So the final application is a composition of multiple small features. Of course, you have a lot of advantages, because you can deploy each single component independently. You can scale them independently. Oh, seems to be very amazing. So now the point is, where is Magento 2 now? And the most obvious answer for most of the people should be between spaghetti, lasagna, ravioli. I know most of the people will answer spaghetti, but no, it's not spaghetti. But you would say, hey, it's ravioli, of course. Well, not exactly, because Magento 1 as well as Magento 2 till 2.2 actually is almost there. It's not exactly there. But something changed. Yeah, well, I forgot this. So something changed in Magento 2.3 after, I think, this is my interpretation again, probably the breaking point was another one. After one of the most advanced projects was introduced, the previous name was MSI, now it's known as the inventory project. And I think after this, we get a new approach in Magento that you should know, because if you're facing Magento for the first time and you're looking into the Magento code base, you're probably finding a lot of legacy code. And maybe I don't want you to take bad behaviors coming from the past. So I think this is the right place to find information. And honestly, I have to thank a couple of guys for the MSI contribution that are, one of them is here, is Igor Miniaglio. He is mostly the father of MSI, and Eugene Shak, Eugene. I told you, yeah, I have a problem with Polish name. You can imagine with Ukrainian one. And basically, if you have time to speak with them, they can give you a very nice insight about this. And they are very powerful people. So this is, yeah, it's Igor. And what is this new thing that was introduced? Actually, we cannot say that Magento is exactly moving to microservices, but it's moving to service isolation. Actually, as far as I know, but I don't know if I'm wrong, Igor is going to have a speak tomorrow about this service isolation. So if you want to go deeper on these aspects, probably that is the right opportunity. So What is service isolation? In the previous approach of the layer monolith, I told you basically the software was developed horizontally. And this is, we already explained this. In the service isolation, the software is developed vertically. So basically, each module is developed independently, and it can be layered inside. It is not a problem. But we all know that I told you before that the problems come from the interaction between modules. And how can it be solved? Well, the solution is quite simple. You can split the modules into two different parts. So one is the API part. I will explain you later what exactly means. And one is the implementation itself. So if you're familiar with, for example, solid principles, well, I will face this later, maybe. So basically, the customer API is a kind of abstraction of the module. So it's made of interfaces, while the customer module is the implementation itself. So basically, when a module needs to require something from another module, should be depending on the abstraction. If you're familiar to the solid principles I was mentioning before, you probably know that you got the dependency inversion principle. That basically means that you should be depending on the abstraction, not on the implementation itself. This is almost the same brought at functional area level or at module level. So basically, if you want to have an interaction, you should only be depending on the API or the interfaces or whatever you want to call. This leads us to the API-first approach. So basically, when you want to develop something new or when you want to study an existing module in the part of Magento that was developed following this principle, you should start from API. This means that before you write the interface, so this is even easier from the developer's perspective because it allows you to focus on what the module has to do, not on the implementation. So basically, you create all the main methods to access the information or to do the job that this module is supposed to do. Then you implement the concrete module. This is even very useful if you, for example, work in team, because creating, for example, the interface allows you to mock the implementation. For example, they move to the next department. Sometimes I use it when we are in a teamwork and you have a backend implementation that is requiring time. We focus on the interface, we create a mock implementation, and we push ahead. Then we replace the mock implementation with the real implementation. Yeah, this is what I was telling you before. So basically, it's the same of the dependency inversion, but moved at module level, no more at code level. This means basically that if we got one module and another module, funny names, yeah, very important names. If my module is depending on another module, should be depending on its abstraction. And another module should be, of course, depending on the abstraction of itself. This makes basically another module replaceable. This is what I was telling you before. So basically, this is useful in the teamwork, but useful even for some strong customization. Because if you follow this principle, basically, you don't need to replace the other module API because the other modules are connecting to that module, but you can replace just the implementation. And it should be working because you are basically respecting all the interfaces. It's like a list code substitution at module level, basically. This is what actually an API modules look like. It's just full of interfaces. It's very uncommon to find an implementation inside one API modules. If it happens, usually it's because it's part of the interface itself. It can happen, for example, that in model you find some concrete class, but it means that it's part of the interface itself. Okay, now we got one problem about the cross-context interactions to move to this kind of service isolation. So this is a real example in the inventory project. So you get inventory, and as you can imagine, it has dependency on sales and vice versa. And in the old implementation, actually, you had this kind of mutual dependency that you know is quite bad because it means you have modules but not modularity, because you cannot simply remove, let's say, inventory and have sales or vice versa. So we have to solve this in some way. And for example, in the inventory project, they managed to solve this by creating a kind of decoupled dependency. So introducing a new module that is the inventory sales, for example. So it's a kind of, allow me to say, a kind of adapter for inventory to access the sales information. So basically, they are not depending anymore each other, but they can be connected using this module that basically is using all the tools that Magento provides you, like plugins, like sometimes preferences, to rewrite what is needed in inventory to access sales and vice versa. In this way, if you have both of them, you should also have these third modules. Otherwise, these modules can be removed, for example. Of course, Magento is not still ready for this, but this is the direction where it's moving. So in the future, I assume that probably one module can simply be removed or not deployed. To do this, I don't want to explain exactly why, but if you will go deeper in the Magento world, probably you will understand why. But we will need smaller classes to do that. Because of pluginization, because of preferences. I don't want to go deeper in this aspect now, but just trust me, you will need smaller classes. This is a kind of extension of the single responsibility principle of the solid programming. Because basically, in the old way, you had classes that were quite big, and sometimes most of us probably created one class called library, containing all the stuff you didn't know exactly where to place. Well, actually, this is exactly the opposite. So if you have one class doing a lot of things, you should be splitting into multiple classes. This is why in Magento, in the new way of implementing Magento, you will find small classes with sometimes just one single method. This is why. And mind the name, because the name of a class is very important, because reduces significantly the cognitive load. So basically, just looking at the files list, I should be able to understand what this module is doing. So basically, I always say that if you have problems naming the class, then you probably need a refactor. This is what I usually say. And this is an example. This is a real class. And you can see this is a specific type of single responsibility class, because this is a kind of functional class. Actually, if you're coming from the JavaScript world or the Python world, you probably are familiar to this. When the responsibility is an action, usually you have only one public method, and it's called execute, and the class name should start with a verb. If the class doesn't start with a verb, usually the responsibility is not an action, but it's something different. So an example is product repository. Of course, it's not an action, but the responsibility of the class is to handle the repository of products. So it's quite clear. And of course, do not use classes with thousands of public methods. This is quite easy. You have a corollary of the single responsibility, because you should be preferring class composition over extension. Why? If you're a PHP developer, you probably know that most of the developers use extension of a class inheritance for code reusage. This is, of course, a bad behavior, because you should be using inheritance because you need inheritance. But most of the people, simply because they want inherit methods, not behaviors. So Magento actually prefer this approach of composition. So basically, if we had class A extending B, a class B extending C, in which I had all the feature of all the classes in the class A, I simply say I got 3 different classes, and I'm calling class B and class C inside class A. Of course, this is much more convenient, especially because in PHP, you probably know you don't have, you cannot inherit multiple classes. So this is going to have some limit, some limitation. And this is the preferred approach. So where is going now Magento? So you're ready to understand what you will need to understand the future of Magento. Well, actually, Anton Kriel, this is the Anton Kriel vision of Magento 2. I don't know if it's updated, but Anton Kriel is sitting there, so you can ask him directly. He is the director of architecture at Magento and master of the universe. And probably the future of Magento is something like this. So today you will find, for example, one single module for catalog, but in the future could be like this. So if you want to start developing a new module, you should be following a different approach. So basically, splitting this module in multiple parts. You can see, for example, catalog API I was mentioning before. You got catalog, that is the engine implementation of the catalog itself. You got catalog PWA, that is supposed to be the part of the catalog to expose to the PWA application, and so on. Catalog GraphQL and whatever. This brings to the what I call module Geddon. That is the most obvious consequence, and it is very scaring because this is the. It is not more. It's not so clear from this slide, but anyway, only the inventory project has something like 40 modules. So one single functional area is made of 40 modules, and usually when the people approach this new scenario, the reaction is this one. The first reaction. The second reaction is also called near-death experience. But if you survive, you can see the light, actually. Because, yeah, first, I want to say, don't be scared, because most of them are made by simple classes, and you just open them, and as I told you before, simply reading the file name of a class, you can understand what it's exactly doing. This is a kind of coding heaven when it happens. And second, adding a new folder is free. You don't have to pay to add a new folder. So don't be scared to add modules. It's not a problem. Most of the people are just scared because they say, oh, I have to add a module. What is the problem? Are you paying the module? No problem. So why? Because you realize you have a fully modular system and you got a full service isolation. You have a clear code writing. If you come from the world of Magento 1, you probably know that most of the time, the problem is to find where something is happening. With this new approach, it's very simple because you got inventory sales. You know that is probably the relationship between inventory and sales is happening in that module. You have a class that is named get products by SKUs, so it's quite easy to understand what is doing. And you have very few side effects. And so on. And, oh, the last one, you have no more God modules. So that huge modules like the catalog modules we had in Magento 1 that was super huge and everything was there. It was impressive. But we forgot something that is much more important than, well, the same importance, I think, database. Database is another part that needs some scalability and isolation. So, if we want to isolate all that modules, we must mind the database, because potentially we could be running all the functional area in the future in different database, or maybe run on the same machine and connect to different database. And we got one problem. This is the problem. So again, this is again inventory example. So you got the source item that basically is I will simplify it, the quantity of the product. It's not exactly this, but it's fine. And you get the product, and usually you create a foreign key from one table to the other. How can you scale this? Because you cannot disconnect them, because you can have a foreign key only on the same database. So basically the solution is quite simple. Do not use foreign keys. But if you don't use foreign keys, we'll see later why, you will need to use this one, so a business key. So no more one ID, but something that is a kind of speaking identifier. It's called business key because the product queue makes sense to identify the product, while the product ID is something that is only database related, so it's not business related. Why? I need to open a parenthesis about the CAP theorem. Raise your hand if you ever heard about the CAP theorem. Oh, this is not so rookie track at the end. So CAP theorem. It says that in every database, it doesn't matter if you have MySQL, whatever SQL, or what you like SQL. You got three aspects: consistency, availability, and partitioning. And this is cool, but the bad news is that you can only have two of them at the same time. So you will never be able to have one database that is consistent, available, and partitioned. Partition means, of course, split it across different databases. So we got to choose two of them. We said we want partitioning because we want to split across different databases. We are dealing with an e-commerce, so I suppose that availability is a good idea to have. So basically, we have to remove consistency. At the very beginning, it's, what? Remove consistency? What do you mean exactly? It means exactly this, remove consistency. But it's not so scary, because it's scary if you think to the software like you were doing before the speech. But if you think to a new way of approaching the software, it makes sense. The eventual consistency. This is a topic that I think can require at least 2 speeches in 2 months, of 2 months each, but I will try to make it simple. So in the old approach, if we add consistency, basically when you write data and you immediately read the same, require the same data, you gather exactly the same data. So it's quite simple. If I save a product and I get a product, I have the information. This is cool. This is fine. But if we are in a partition system, basically the two systems to be aligned or connected, they may require time. So basically when you write data and you read data from the other side, you may read an outdated data. So probably we need to change this approach in something slightly different. First, we have to understand what is CQS. Have you ever heard about CQS? Yeah. Anton Krill, of course, heard about this. Yeah. So CQS is common and query separation. You have to follow me now, because you will understand why consistency is not so more a problem. So in the CQS, we have a separation between what is a common and what is a what is a query. So basically, a common is something that modifies the persistence layer, so the database, while the query is something that reads. There's nothing complex here, but they have rules. The command must not return anything from the database because of the reason I told you before, basically. So if we have an hypothetical save method or create method of a product, it was a common behavior to get back the ID of the newly created product from this method. This is not possible anymore. And this is another reason why you should be using a business key. So for example, SKUs, because it's predefined before saving into the database. So if you need to reference somehow, you have that key. And this is the main rule. So it should be a void method, a void returning method. The query, of course, is something that reads the database, but never and never must modify the database or the application state. So for example, if you have a method that is getProduct, of course, it should not be having side effect or saving something to the database. Yeah, you say it's quite obvious. I can assure you that is not so obvious sometimes. Then this brings us to the CQRS. That is someone says that is a kind of evolution CQS. This is bullshit because it's simply something different. Because CQRS is inheriting everything about CQS, but adds something: responsibility segregation of common and query. What does it mean? That you write data in one way with one representation, and you read data with another representation. I have an example later. Because you have to think that when you isolate modules, you can even isolate the logic between the modules. So it is not said that the product representation for the catalog is the same of the representation in the cart. So basically, they can change the representation. So you write in one way, and you read another way. This is a real example in the inventory. So basically, you write the quantity and you write the reservations. The reservations are basically the quantities that have been ordered but not yet shipped. And from the other side, you read the sellable quantity. So basically, you write with one representation and you read with another one. This is an example, of course. So where can you find good examples? As I told you before, looking at the Magento code sometimes is not a good idea. Because as I told you before, Magento 2 has a huge amount of legacy code, and I don't want to express about this legacy code, because otherwise they will remove my mastership, I think. I'm joking. Of course, we are human, and they evolved from... I'm taking this, there was an evolution between Magento 1 that had one idea behind to Magento 2, so it is not an easy process to follow. This is an evolution. Magento 2 is continuing evolving, I'm sorry. So where to find good examples? I told you before, inventory project, also known as MSI, and the notifier project, that actually is one module I wrote, so yeah. Super. Well, actually, they're the only two examples that I know they're implementing good service isolation. Of course, probably other projects are existing, but I don't know them. Maybe if you can tweet them, I think you can help the whole community. So you can use them to have nice examples on what I'm saying now. And another tool I suggest you to use is Slack if you're new to this world, because Magento is not only an open source product, it's a very open source community. And you have all these guys from the Magento community engineering that are always ready to help you. Actually, you have to thank them for a lot of things, because before knowing them, I was sure I was a good developer. After knowing them, I understood I was a shitty developer. But this is called evolution. When you look back to your code of 2 years ago and you say, was I drunk? And you were so proud of that code, and now you would like to burn GitHub because you don't want to see it anymore. So I'm done, and thank you very much for your time, and that's it. So I think, quite super fast, because I know we are running out of time. So if you have questions. Yeah.
What about transactions?
Yeah, well, actually, yeah, you have almost the same problem. But when you, Igor just started, because he's a very, I think maybe you can have a nice discussion with him. But of course, when you deal with transaction, you deal with consistency. But if you, I think that if you start facing the software with this new approach, actually the transaction does not become any more a problem, because when do you need a transaction? When you need basically a consistency across multiple operations. You can use transaction, of course, internally in your module, but of course, when you're dealing between service isolation, you cannot have transaction between different modules, and your software must be written in consequence of this. But if you follow, for example, the CQS principle, I'm not talking about CQRS, but only the CQS principle, sometimes you don't even need, actually. So to be answering to your question, actually, I need to explain you to give you some example. So maybe we can do it later, because now it's very hard, and it requires very high abstraction to explain. Seems it's enough. So thank you again for your time.